Okay, in this video we have the integral of the square root of e to the 2x minus 1. Looks like a substitution, a U-substitution. You want to stop the video and try this out? I'll be right back. So this is one where you could let u equal to the square root of e to the 2x minus 1. And then you can compute du from here. I found that it's a little bit easier in the calculations if you square this first. Squaring both sides, I get u squared. And then over here I get on the right side e to the 2x minus 1. Now I compute the du here, taking the derivative or differential here. This will be 2u du. And on the right side, taking the derivative, and this is a minus 1 here, not 2x, not e to the 2x minus 1, so this is this. Then take the derivative of a negative 1 is 0. The derivative of e to the 2x is e to the 2x times the derivative of the exponent. That'll be 2 here. So you can see that here this 2 and this 2 then will cancel. And I have a dx right here. Now you could go ahead, where I have u equal the square root of e to the 2x minus 1, you could just go ahead and find du from there. I find it's a little bit easier if you do it this way with the calculation. So that's going to equal 2. It's the integral then, and this is u. And then over here then we can say dx, dividing by e to the x, dx will be u du over e to the x. So this dx right here then is replaced by u du. That's over e to the x. So this is going to equal 2. Got u times u, that's u squared du. And then here replacement. We're trying to convert this to an integral involving just the variable u. You want to eliminate the x variable. So from this equation right here, adding 1 to both sides, we get u squared plus 1, and then plus 1 over here cancels the negative 1, so I get another way to write e to the 2x is u squared plus 1. So then this will be u squared plus 1. Now we got everything in terms of u. You could go ahead and just divide, use some long division, and divide u squared plus 1 into u squared, and you'll get the same thing I'm going to do here. And I've done that in several other videos. But what I'm going to do here is in the numerator, a popular trick in math is to add 0. So I'm going to add 1 here and subtract 1. Even in more advanced mathematics, doing proving theorems, this is done quite a bit. Adding 0 to an expression to give it a different look. So we get this. Then what we're going to do is just rewrite this into 2 integrals. So let's just put this together, this part together. So that'll be u squared plus 1 over u squared plus 1. Well, that's just 1. And then you got the du. Breaking it up into 2 integrals. And then that'll give us a minus over here. And then that'll be the integral of 1 over u squared plus 1 du. Now we're ready to integrate here. The integral of 1 du, that's with respect to u, this will just give us u, minus, and the integral of 1 over u squared plus 1. This, of course, is the one that generates tangent, arctangent, I should say. So this will be arc tangent of u over 1. In the actual formula, this is u squared plus a squared. But 1 squared is 1. So the a in that formula is 1. So the formula says it's u over 1. That's just u. And then a coefficient, that's 1 over a in front. But that's just 1 over 1, which is 1. So that stays the way it is. And then we have the constant of integration. We got that. And now we just go back to the original variable. That's always the case when you do a U-substitution or a trigonometric substitution. You basically find the antiderivative or the integral using that substitution, but then you go back to the original variable. So u is the square root of e to the 2x minus 1. So we just go back and replace this u by e to the 2x minus 1, and then minus arctan of u, and u is the square root of e to the 2x minus 1, and then it's plus your constant of integration. So again, square root, answer, get the square root of e to the 2x minus 1 minus arctangent of the square root of e to the 2x minus 1 plus the constant of integration. Thanks for watching. We'll see you next time.